So we're going to look at mixed numbers and writing them in fractional form. Mixed numbers means you've got some whole numbers. In this case we've got 3 wholes and some part numbers. So we've got 3 wholes and the part, or the fractional part, is 2/5. So what we have to do is we have to change this into a complete fraction. So that 2/5 is already a fraction, but we also need to change the 3 part to a fraction. So if we look at the 3 wholes, we know that there are 5/5 in each whole. So there's 5 there, 10 to 2 wholes, there's 10/5 in 2 wholes, 15/5 there. So we've got the 15/5 in 3 plus the 2/5 gives us 17/5 altogether. 17 over 5. Okay. So what we've done is we've changed a mixed number into a fraction. Because it was mixed and it was over a whole, it was bigger than 1, we notice that it's an improper fraction. So we have a higher or a larger numerator than the denominator, and this is showing us that this is a number that's bigger than 1. It's not something we're used to seeing as a fraction, or that we think of as just a fractional part of 1. It's a mixed number. It's whole numbers and a little bit of parts. So 3 and 2/5 can also be written as 17/5. Let's try the next one. Here we have, 3 and 2/5. I think we did write it as 17/5. Okay to that, correct. Next example, I'll shrink this down because I think it's offset on me. No, here was good. Okay, this one here we see as the part 1 is 12ths. So we have 7/12 in this pink here, and we've also got 3 wholes. Each whole has got 12/12 in it. So I take the 3 and I multiply it by 12 to understand that in 3 we have 3 times 12, 36/12 plus 7/12. 36 and 4 is 40, and 43/12 total. Correct. Next one, we have 1 and 1/3. In 1 I have 3/3, so I've changed 1 already to 3/3, plus this extra third, so I have 4/3 altogether. I guess what's really good for you is with some of those bigger ones that we did before, you can go back and have a look if they seem to go too fast. But this is an easier example, so you can see 4/3 is 1 and 1/3. Next example, we have 3 wholes, so looking at it here, and 5/6. Within the 3 wholes, each whole has 6/6. So 6, 12, 18/6 in 3. 19, 20, 21, 22, 23. Okay, so we multiply 3 by 6 is 18, so we multiply, if you just take a look at this fraction here, 18, 3 6s are 18, and then we plus the other 6s, because we've got 18 6s in the 3, so we times 3 by 6, 18, plus the 5 is 23. 6s all together, and that's, if we counted all these little guys here, we would count 23 of these size bits, these size fractions. Correct. New example, we have 1 whole. How many's? I'll try 1 out of 1 because I can't see any smaller fraction. So when we write 1 whole as a fraction, we can write it as 1 out of 1. Correct. Next example, 2 and 1/3. I can see 7/3 there. Beautiful. So 2 and 1/3 is equivalent to 7/3. Improper fraction or fractional form, mixed form, number and a fractional part. Next example, 1 1/2, altogether 3 halves. There's 2 halves in 1 plus the other 1 left over. 2 1s are 2 plus 1 is 3 halves on the top there. Next example, 2 wholes written as a fraction, I'm going to write it as 2 over 1. I could have written 4 over 2, 4 halves, but 2 over 1 is the simplest way that I can write 2 in a fractional form with a numerator and a denominator, 2 once, because I have a 1th there, or 1 there, and a 1 there. So I can write that as 2 once. Cute, eh? So that's correct. I think it is. 2 1/4, I have 4 fourths in 1, 8 fourths in 2, plus the extra 1. What's it going to be? You got it, 9 fourths. Cool. Okay, next one here, 3, we can quickly write that as 3 once, and we're good with that. And next one here, it's nearly 3, isn't it? It's 2 8/9. We're 8/9 of the way along to 9/9. So I've got 2 times 9 is 18 to the 2, 19, 20, 26 ninths. Correct. Okay, let's have a look at some circly ones before we move on. My first one here, so instead of looking at this bar, this number line, I'm going to have a look at this as pies or circles. So I've nearly got 2. I've got 1 whole and 3/4 extra. Altogether, I write that, remember, as quarters. So 4 ones are 4, plus 3 is 7/4, and you can count them, you can see them there, they're nice simple numbers. 4 there, 5, 6, 7/4. Okie doke. Next one, 1 and 3/10, there's 10/10 there, plus 3, 13/10 altogether. No issues there. All correct. Next one, I can see 8ths, 16/8 and 2, 2 8ths is 16, and 5 makes 21, I think. Correct. Next example, I can see 3 wholes. I can write, now I can see the 3 wholes not as 3 clean dots, but I can see quarters there. So I need to write the denominator as quarters, and I recognize that I've got 3 lots of 4/4. 3 lots of 4 is 12/4. All good, and that's what it expected. It expected it to be written as 12/4. I could have written 3 over 1, which is the simplified version of that. Okay, I have 1 there, I can write that as 4/4 or 4/4. Still correct. Very good. Next one there, 1 and 4/10, 10/10 there, so I'm in tenths always writing it as the same base or denominator as the fractional part. I think about the whole as a fraction. 1 times 10 is 10/10 there, plus the 4/10 over, or added on to the whole number, so 14/10. New example, 2 and 2/3, 2 3s is 6, plus 2 is 8/3. Let's see if there's anything else dishy along here. Oh, that's a nice one. 2 and 2/12, 2/12s are 24/12 in the 2 wholes there, and plus the 2/12 over is 26/12. Correct. And 1 and 3/8 is altogether 8/8 there, because 8 ones are 8, plus 3 is 11/8. Okay, so there's a technique for going from mixed to fraction form, whether you have rods or circles. We're going to have a look now, fraction form to mixed form, and we'll start with rods. I can see 11/4 there, I can see 2 full wholes, so that's dealt with, and then I see 3 out of 4 parts of this next whole towards 3. And it hasn't reached 3 yet, it's 3/4 of the way, 3/4 of the way towards 3. Okie doke, 2 3/4. Okay, I've got one hole there and another 1 2 3 4 5. So I've got one hole and 5/8. Now if we didn't have a picture of it and I was just looking at this fraction here, I need to do it this way. I need to do it numerically, using the numbers or mathematically. I need to say how many clean whole 8s can go into 13. Alright, how many 8s, how many times can I make 8 before I reach 13? Well, I know that 8 ones are 8, so I can make it once. Can I make it twice? 8 twos are 16. I've gone beyond 13, so I haven't got 2. I've only got 1. So I've got 1 8 in 13, and that just makes 8, but I've got 13 there. So if I take away 8 8s, then I have 5 left over. Alright, so that's the way we do it. We say how many 8s in 13? It only goes in once clean, and if we take that 8 or that 1 off 13, we have 5 parts left over. Okay, let's use that method for the next one. How many 3s in 5? It only goes in once, otherwise we'd have to get to 6 to go in twice. And if 3 goes into 5 once, then that takes care of 3/3 of that 5/3, so I've got 2/3 left over. Okay, so 3 goes into 5 once, and then I think about taking that 3 away from 5, leaving me with 2/3 left over. Okay, 5/3 is 1 2/3. Now I'm going to labour this a little bit. I'm going to explain it because you may be missing it there. So 5/3, how many thirds go into 5? Well, I can only get 1, okay, and 1 is 3/3. But I still have 2/3 to take care of. Yeah? That's why I'm saying that one lot is 3/3, because 3/3 plus 2/3 made my 5/3. This 3/3 is 1, and this 2/3 is left over. Alright, so I'm breaking down 5/3 to 3/3 and the other bit 2/3. Let's go back. That's why it was 1 and 2/3. Let's try the next one. 11/5, using my division. 11/5. How many 5s in 11? Clean 5s. Well, that'll be 2 holes. And that takes care of 10/5. But I've got 11/5. So I just don't have 10 in my original fraction. I've got 10/5 and 1/5, which is 2, this bit along here, the whole part, and 1/5. 2 1/5. So back we go. I've got 2 and 1/5, and I can see it there using my diagram. That helps me to see it. Next one, 17/6. How many times does 6 go into 17? 6 3s are 18, so I don't quite get 3, but I get 2. 6 2s are 12. 12 off 17 leaves 5. 5 what? 5 6. So there's 2 6 is 12, 13, 14, 15, 16, 17. Hope it makes sense to you. Let's try one more. That's an easy one. How many thirds go in 4th cleanly? Just once. And 1/3 left over. 1 and 1/3. Come on, bring up a hard one. 17/12. 12 goes into 17 once clean. And we have 5/17 left from that. So we are pulling away the whole part. How many times 12 goes into 17? Or how many 12ths we could get from 17? Only one whole, and then we have this remainder part. Too small. 2, 3, 4, 5 12ths. If I was talking 17ths, you want to go back and think about 12ths in my last little chatter there about that one. 29 ninths, 9 goes into 29. You can see that it's 3 and something, 3 and 2 ninths, but I want to look at it from here. 9 goes into 29, 9 threes are 27, so we've got the 3 wholes, but we have 29, so we have 2 ninths part left over. Notice how we're doing division. We're dividing 29 by 9 bits. Next one, 7 sixths. 6 goes into 7 once and 1 sixth over. Five thirds, 3 goes into 5 once clean to make 3, and 2 left over, 2 fifths. 2 thirds, my bad. I'm getting all muddled up with my numerators now. So there. Okay, 12 into 43, 12 threes are 36, and looks like 7 twelfths left over. So 7 that we can't push a further 12 into. Only 3 12s at 36. So that one was correct. Alright, 10 thirds, 3 goes into 10, 3 threes are 9, and 1 made our 10 thirds. Always thirds, always matching it back to the original fraction. Okay, done the rods. Let's look lastly at these are the same really because we're using the same process, but we look at circles again for going from fraction to mix. 6 goes into 14 twice, that makes 12, but we have 14, so that's 2 sixths over. It likes it. What else could I have written there? I could have written 2 wholes, and I know it was 2 sixths over, but I should recognize that 2 sixths is also 1/3. So more correct would have been to actually write 2 and 1/3. I wonder if I can change it. Let's have a little quick look. 2 and 1/3. Oh, it's next example time. 5 thirds, 3 goes into 5 once cleanly, and 2 parts left over. So 2 fifths. 2 yet to be divided by 5, right? 2 thirds. You knew that. I'm just testing you now, I'm just tricking you. 9 into 35. 9 fours are 36, but 4's too big because we don't have 36 ninths, we have 35. So we can only have our 3 parts. And I'm just looking at this because I'm tired now. I know there must be 8 ninths left over because we have 1 white square. Correct. All done. Kuti nighty. Good night.